Hi guys, so this is my video for the demonstration for my fan project, which is a CPU temperature monitoring utility. I'm gonna turn on my Raspberry Pi. You see that the screen does turn on, but it's still not booting. It's going to take some time. And I built this image using Yocto build system. It includes a GUI, which is basically running based off of an X11 GUI. And right at the boot, you can see that my I2C driver for Linux has loaded, and it's showing me the Linux core, the CPU core temperatures in real time. It's being updated every second. And at the same time, you can see that my fan is also powered on, which is being driven by a PWM. I'm using a really simple linear algorithm to kind of tune the duty cycle of this PWM. And I'm going to give you a small demonstration to sort of prove what happens to the CPU core temperatures as I load the CPU. So if I look at the terminal right here, I'm going to launch the terminal. And I'm quickly going to just show you that the LCD driver is in fact loaded, and shows the I2C LCD driver, which is the custom driver that I wrote for this. We're also gonna look for PWM, which shows the PWM fan driver, which is also the custom driver that I wrote for this. Now at the same time, what I'm going to do is, if I look at the present working directory and I do a simple ls, we see that I created a script called loop.sh. And what essentially loop.sh does is it has a while loop which just echoes something out to the terminal. And I'm going to use this simple script to kind of demonstrate what happens to the CPU temps, as well as how this changes. So I run this script, and we observe the CPU temps rise in real time. So notice how we were at 47 degrees when this script started, and this just keeps climbing because now there's just this single process which is utilizing the CPU to 100%, and it's leaving. It's essentially increasing the temperature in the process. My build is also configured to kind of overclock the CPU at 1.1 gigahertz instead of running it at the standard 800 megahertz that it was configured to by default. So to kind of boost this increase in temperature, just to demonstrate what happens. And if I kill the script, we return back to the shell, and in just a bit we can start to see these temperatures drop as the CPU comes back to its normal temperature. And yeah, that is it. That's the demonstration of my the CPU temperature monitoring system that I created. Just as an extra step, I'm going to invoke the top command, and I'm going to show you that I have the thermal LCD bridge, which is basically a script that loads at init. So when this Linux boots, this runs as an init script, initializing this as a daemon, such that it creates a bridge between the sysfs files that the CPU stores its temperatures at, the sysfs file which is being used to update the data on the LCD, as well as on the PWM driver. So yeah, that's the gist of it.